Hi everyone, we're continuing with the table of basic trig values from 0 degrees to 90 degrees. We've talked about the critical columns for sine of theta, cosine of theta, and tangent of theta, but now what about the three reciprocal functions? Remember, what's the reciprocal of sine of theta? Careful, it's cosecant of theta. The reciprocal of cosine of theta is secant of theta. The reciprocal of tangent of theta is cotangent of theta. How can we get these three additional columns and get a very complete grid with 30 values, by the way, if you count undefined as a value? And again, I claim that you can do this within a minute. I think within a minute. All right, so how do we get from sine of theta to cosecant of theta? Sine of theta to cosecant of theta. We can use the reciprocal identities. Remember, cosecant of theta is 1 over sine of theta. Let's work it out. All right. So to get the cosecant of theta column, well, the reciprocal of 0 is undefined. 1 over 0 is undefined. The reciprocal of 1/2 is 2. The reciprocal of this thing, remember, the unrationalized version is 1 over root 2. The reciprocal of 1 over root 2 is root 2. Moving on up. Moving on up. The reciprocal of root 3 over 2 is 2 over root 3. That rationalizes as 2 root 3 over 3. The reciprocal of 1 is 1. So I claim that the cosecant column is basically given by these values over here. Undefined, going down to 1. All right, now let's say that we wanted to get the values for secant of theta. We could go ahead and take the reciprocals of these values, but now wait a minute. Wait a minute. Let's think about this. How do we get from the sine column to the cosine column? We reversed the sine column to get the cosine column. Guess what? To get from cosecant to secant, we can do the same thing. We flip or reverse the cosecant column to get the secant column. And the reason is, cosecant of theta and secant of theta are cofunctions. Cosecant and secant are cofunctions, just as sine and cosine were back here. So one really nice feature of this table is that to get columns for cofunctions, you just flip one column to get the other. You flip the sine column to get the cosine column. You flip the cosecant column to get the secant column. And guess what? You can reverse the tangent column to get the cotangent column. Maybe reverse is a better word than flip, because I don't mean flip fractions. I mean reversing the column. Okay, so again, remember that cosine of theta is x, sine of theta is y. So when you consider the corresponding intersection points, by the way, I'll erase these. When you consider the corresponding intersection points, remember that the x-coordinate corresponds to cosine of theta, the y-coordinate corresponds to sine of theta. So for 0 degrees, the intersection point of the terminal side with the unit circle will not be 0, 1, it'll be 1, 0. X here, y here. Cosine first, and then sine. Cosine first, and then sine. All right. And by the way, when I talk about this unit circle here, this is what I'm talking about. I'm talking about these intersection points. So for example, for the 60-degree angle, all right, for the 60-degree angle, we saw that for the 60-degree angle, the corresponding intersection point was 1/2, which is the cosine value, comma √3/2, which is the sine value, cosine comma sine. 1/2 comma √3/2. Over here, 1/2 is the cosine value, √3/2 is the sine value, x comma y. The big picture, if you consider all the special angles from 0 degrees to 90 degrees, looking counterclockwise as usual. All right, at this point, for 0 degrees, the corresponding intersection point is 1 comma 0. Remember, the cosine of 0 degrees is 1. The sine of 0 degrees is 0. Cosine is x, sine is y. Likewise, hey look, the sine of 30 degrees is 1/2. The cosine is the high number, √3/2. The 30-degree angle gives us a point that's low and to the right, a low sine value and a high cosine value. Low y, high x. The 45-degree angle gives us this point here, where x equals y. And the slope, the tangent value, is 1. For 60 degrees, this time the cosine value is low, it's 1/2. I know that 0.5 isn't that low, considering we're talking about numbers between 0 and 1 here, but it's a lot lower than this guy. Remember, √3 is about 1.7. This thing is pretty close to 1, actually. Again, √3 is about 1.7. Over at 90 degrees, 0 comma 1, the cosine is 0, the sine is 1. All right, cosine comma sine, x comma y. Cosine gives us x, sine gives us y. 30 degrees versus 60 degrees. I like to call this point the talk radio point. I like to call this point the Hippie point. The 30-degree point is the talk radio point, low and to the right, like Rush Limbaugh. The 60-degree point is the Hippie point, high and to the left. That's my little joke. That's meant to be offensive to both right-wingers and left-wingers alike. Okay, so 30 degrees, low and to the right, 60 degrees, high and to the left. Again, if you remember that sine of 30 degrees is 1/2, the low number, cosine of 30 degrees is that high number, √3/2. For 60 degrees, they're switched. For 45 degrees, these values are equal. And again, for the quadrantal angles, just be really careful what point you're talking about. Remember that this point is 1 comma 0, and this point is 0 comma 1. Now, speaking of the 90-degree angle, there's a really great trick that some very clever students came up with. All right, this is a great trick over here. A couple of students came up with this. For the 90-degree angle, pi/2 radians, sine of 90 degrees is 1, cosine of 90 degrees is 0, tangent of 90 degrees is undefined. Can you see why the way I wrote these three abbreviations here really helps us? Sine of 90 degrees is 1. I is the Roman numeral for 1. Cosine of 90 degrees is 0. The O here looks like a 0. Tangent of 90 degrees. Why an A there? Well, if you graph y equals tangent of theta, what happens at theta equals 90 degrees or pi/2 radians? You get an asymptote. Theta equals pi/2. Maybe x equals pi/2 is better. Yeah, x equals pi/2, vertical asymptote. There's also another vertical asymptote at x or theta equals negative pi/2 over here. We'll talk more about these later on. All right, so for 90 degrees, because I know that mentally we might be too lazy to move from here to here, right? Let's get straight to the point. Literally straight to the point up here. 90 degrees. Sine of 90 degrees is 1. Cosine of 90 degrees is 0. Tangent of 90 degrees is undefined. That's why we have an asymptote at x equals pi/2. Again, tangent is slope. a previous hint over here. Remember, tangent is slope. The tangent values. It's 0 here. It's root 3 over 3 for 30 degrees. Okay, root 3 is about 1.7, so this is about 1/2, a bit higher. Tangent of 45 degrees is 1. Sine over cosine gives us 1. That's the slope of this blue line segment over here. Tangent of 60 degrees, this over this, that's root 3, which is about 1.7. Tangent of 90 degrees is undefined. It's kind of like infinity if you're coming in counterclockwise here. Again, tangent is slope. What's happening to tangent? It's increasing. 0, a bit more than 1/2. 1, about 1.7, going towards infinity, corresponding to the fact that tangent of 90 degrees is undefined. So the table demonstrates all these wonderful patterns that all make sense and they're all consistent. Next time, we're going to brave into the other quadrants, 2, 3, and 4, and talk about the related angles in other quadrants. That's next time.